Section 4.5 is on completing the square, and this is another technique that we're going to use to solve quadratic equations. But first we need to talk about the square root property. The square root property is taking the square root of each side of an equation in order to solve it. So let's take a look at our first example here. Solve x squared minus 12x plus 36 equals 25 using the square root property. So what I need to recognize first is that this trinomial to the left of the equal sign is indeed a perfect square trinomial. X squared is a perfect square, 36 is a perfect square, 6 and 6, and 12, this negative 12 in the middle, is 2 times x times 6. So this can actually be factored into x minus 6 squared. A minus because there's a minus in front of the 12. And that equals 25. So now I have a perfect square on each side of the equal sign. So I can take the square root of each side, and when I do that on the right here, I want to do the positive or negative square root of 25. So that tells me that x minus 6 is equal to plus or minus 5. I like to write that out as two equations. So x minus 6 equals a positive 5, x minus 6 equals a negative 5, so x equals 11. Oops, I forgot the negative. I was going to say, and x equals a positive 1. Okay, so that's an example of using the square root property to solve an equation. Let's take a look at another example here. On the left-hand side, so I have x squared plus 8x plus 16 equals 20. I know 20 is not a perfect square, but I can still use this. But x squared plus 8x plus 16 is a perfect square trinomial, and that factors into x plus 4 squared, and that equals 20. So now when I take the square root of both sides, I'll have x plus 4 equals the positive or negative square root of 20. I do need to simplify the square root of 20. So that's going to give me a 2 out front and a 5 underneath the radical. So x plus 4 equals plus or minus 2 square root of 5. To solve this, I need to get x all by itself. So I need to subtract 4 on both sides. So x is equal to, and I can't combine those guys, and we tend to put the number out front, negative 4 plus or minus 2 square root of 5. And it looks a little funny, but that is the correct answer. It's just going to be an irrational number. Now, on to completing the square. Completing the square means that you're making one side of an equation a perfect square trinomial so that you can use the square root property to solve. In both of these two previous examples, what was to the left of the equal sign was a perfect square trinomial that could be factored into something in parentheses squared, x plus or minus something in parentheses squared. So if the trinomial is not a perfect square, we can make it be that way. So the steps are, we're going to move our existing c to the right side of the equal sign. So we're going to get rid of our c. Then we're going to find a new c, and that new c is equal to half of b squared. So whatever b is, take half of it, square it, and add that to both sides of the equation. Then we're going to factor the left side because it will be a perfect square trinomial because we made it that way. Then we'll use the square root property and solve for x. Let's take a look at a couple examples here. Oh, actually, before we do that, let's practice finding the value of c. Find the value of c that makes x squared plus 12x plus c a perfect square trinomial. So I'm going to use the little formula, c equals b over 2 squared. And in this case, my b is 12. So half of 12 and square it. Don't try to do 12 squared over 4 squared. It'll probably work, but it's just messy. 12 over 2 is 6. 6 squared is 36. So if I had x squared plus 12x plus 36, that would make it a perfect square trinomial. So that's just a little practice in trying to find the value of x our value of c. Oh, we have to continue, but then we have to factor it. So let's go ahead and do that. X squared plus 12x plus 36. I know it's a perfect square trinomial because I made it be that way. So it's going to be an x, and since there's a plus in the middle, take the square root of 36, which is 6, and squared. And that is what it is factored. So let's solve each quadratic equation by completing the square. So my first step is to take my existing c and move it to the other side. So that's going to be x squared plus 4x equals 12. Notice I left a space because now I want to find my new c. c is equal to b over 2 squared, 2 squared, which is 4. So my new value of c is going to be 4. So I'm going to add that to both sides. I'll kind of do it underneath so you realize that's a separate step. So now I have x squared plus 4x plus 4 equals 16. And I know that this on the left side is a perfect square trinomial because I made it be a perfect square trinomial. And I know it will factor into an x, and since there's a plus in the middle here, and then take the square root of c. So it factors into x plus 2 squared. Taking the square root of both sides, I'll have x plus 2 equals plus or minus the square root of 16, or x plus 2 equals plus or minus 4. I like to write it out as two equations. X plus 2 equals a positive 4. X plus 2 equals a negative 4. So x equals 2, and x equals negative 6. Let's try another example here. X squared plus 6x minus 18 equals 0. First step is to make the left side of the equation a perfect square trinomial. To do that, I'm going to move my existing c to the other side. So x squared plus 6x equals a positive 18. Now let's find our new c. c is going to be equal to half of b and square it. 3 squared, which is 9. So I will add a 9 to both sides of the equation. Maybe I'll go ahead and do that in pink so it kind of stands out a little bit here. Added that to both sides. The left-hand side will factor into x plus, because there's a plus here, 3, because 3 is the square root of 9, equals 27. Taking the square root of both sides, x plus 3 equals plus or minus the square root of 27. 27 factors into a 9 and a 3 and a 3 and a 3. So 1 3 inside, 1 3 outside, 1 3 inside. X plus 3 equals plus or minus 3 square root of 3. Way too many 3's in this problem. And then subtracting 3 from both sides gives me x equals a negative 3, that's this negative 3 right here, plus or minus 3 square root of 3. And it's perfectly okay to leave your answer like that. Don't give me a decimal approximation. I prefer it exact with radicals. Okay, now this one's going to get a little more complicated because in order to complete the square, my a has to be 1. In other words, I cannot have a coefficient of x squared. So the first thing I'm going to do is divide everything by 3 because I have to get rid of that 3 in front of there. So this is going to leave me with x squared plus 10 thirds x. Do not turn that into a decimal. And I'm going to combine a step here and I'm going to move that negative 8 thirds to the other side. Okay, so here it's going to get a little complicated because I need to do half of b and square it. So my new c is going to be 10 thirds And half of that, remember that dividing by 2 is the same thing as multiplying by 1/2. Dividing by a 2, because remember I would take my b, which is 10/3, and put it over 2. It's the same thing as multiplying it by 1/2, and then square it. So that's going to give me 10/6 squared. Let's simplify that a little more. 5/3 squared. And now just square the top and the bottom. 25/9. Now, don't freak out. It's going to work out okay. I promise. So let's add that to both sides. Let's add 25/9 plus 25/9. Okay? Now, when I go to factor the left side, it looks absolutely horrible. But it isn't, because it is a perfect square trinomial. It's going to start with an x, and there's going to be a plus. And I'm going to take the square root of 25/9. It's the same thing as the square root of 25 over the square root of 9. It's 5/3 squared. This right-hand side, you can do that in your calculator. Leave it in a fraction. Don't go to decimal land. So remember, in your calculator, you can do parentheses 8 divided by 3, close parentheses, plus open parentheses 25 divided by 9, math, enter, enter, and you will get 49/9, which looks funny, but I really like it because they're both perfect squares. In the next step, when I go to take the square root of both sides, I'm going to have x plus 5/3 equals plus or minus, okay, square root of 49 over the square root of 9. Square root of 49 is 7. Square root of 9 is 3. It's not that bad. Now, subtracting 5/3 from both sides. Or actually, maybe, let me write that out as two equations. I like that a little better. So x plus 5/3 equals a positive 7/3. And don't freak out. It's got the same denominator. It's not that bad. X plus 5/3 equals a negative 7/3. So x is equal to 2/3. And x is equal to, let's see, so subtracting, whoops, why did I write a 5 on the bottom? That should be a 3. Subtracting 5/3 is going to give me a negative 12/3, which is the same thing as negative 4. Okay, so the key thing here is if your coefficient of x squared, if your a is greater than 1, you have to divide everything by that. You're probably going to end up dealing with fractions, but don't freak out. Use your calculator and don't turn them into decimals. And our last example, x squared minus 6x plus 25. Let's go ahead and move our c to the other side. Let's find a new c. B over 2 squared, negative 3 squared, which is 9. Let's add 9 to both sides. Factor the left side. It is a perfect square trinomial. This one has a negative in the middle, so I'm going to put a negative there. Square root of 9 is 3 squared equals a negative 16. Next step, take the square root of both sides. We can do this. X minus 3 equals plus or minus the square root of negative 16. And you remember what to do with square roots of negative numbers. We're going to use the imaginary unit. So this is the same as x minus 3 equals plus or minus. Square root of negative 1 becomes I. Square root of 16 is 4. So this is just 4i. And then adding 3 to both sides, I'm going to have x equals 3 plus or minus 4i. And in this case, my answer, my solution, is a complex number. That is, it has a real part, the 3, and it has an imaginary part, the 4i. And actually, it's two complex numbers, 3 plus 4i and 3 minus 4i.